My name is Payal Pagadia, and my other two group mates are Ruchika Gaidani and Ashlesha Patil. Today, we will present the screencast topic on user interface management system. The software for managing user interfaces comes in a variety of guises. The purpose of such software is to assist application programmers to provide good quality human interfaces for their programs. A number of techniques are needed to fulfill that purpose. Interaction technique libraries, which provides a software toolkit of techniques that an application programmer may employ, which may include parsers, logical input devices, icon, editors, menu builders, help, error, prompt tools, screen formatters, window managers. A user interface management system provides some of or most of these techniques but integrates them into a single system. In addition, a UIMS provides some methods of controlling the sequence of user operations. It is common for much of a dialog structure to be specified outside the application program, since it is likely that the dialog designer may wish to experiment with the dialog structure without needing to recompile the whole application program. A project in which is the author was involved 5 had a sum of the characteristics of UIMS in that it separated dialog from control from the application modules. By present day standards, the facilities were not rich. It provided the menu building, error prompt tools, and fixed screen layout. In this paper, we want to refer to software that could be either category UIMS or interaction technique library, and will simply refer to such software as user interface software. It is important that such software can support good quality user interfaces. For example, there is much interest in interfaces which does not compel the user to follow the sequence of steps predetermined by the dialog designer. Instead of a user is presented with a series of software supported controls that can be directly manipulated to achieve the desired result. Until recently, there have not UIMS to support the direct manipulation, but toolkits are produced. In front of you, it is a diagram of user interface system, data management and DBMS, knowledge based system, model management and MBMS, user interface management system, UIMS, natural language processor, input, output, user and printers and plotters. Next, my groupmate will present you.
Roles of standardization. Although standards for user interface software and user interfaces as such are not yet being developed, there are standards for one of the major components, which is the graphics software. One of the reasons for using a standard computer graphics programming interface is to encourage the interchange of application module and complete program using computer graphics. However, using a standard in general can carry the risk of excluding modern techniques. We would like to gain the benefit of standardization and still be able to produce good user interfaces. Principle of user interface. User interface design principles. Principle description. User familiarity. The interface should use terms and concepts which are drawn from the experience of the people who will make most use of the system. Consistency. The interface should be consistent in that whenever possible, comparable operations should be activated in the same way. Outline of interaction.
Outline of interaction in GKS. GKS is a graphical kernel system. The graphical kernel system became an ISO standard for computer graphics programming, and language bindings are being standardized language by language 1 degree. Since there are introductions to GKS elsewhere 11 and to the bindings elsewhere 12, This section will merely highlight some main points that are relevant to designing user interface. GKS controls workstations, which are abstractions of devices. One useful example of this abstraction is on a single user system with the window manager. With a good window manager, each window can be controlled by an application program, which need not be affected by where its windows are placed or by the obscuring of its windows by others. This slide explains the window manager. A window manager is a system software that controls the placement and appearance of windows within a windowing system. In a graphical user interface, most window managers are designed to help provide a desktop environment. They work in a conjunction with the underlying graphical system that provides required functionality, supports for graphics hardware, pointing devices, and a keyboard, and are often written or created using Widget Toolkit. Layers of graphical user interface. Under X, the window manager and the display server are two distinct programs, but under Wayland, the function of both is handled by the Wayland compositor. Typical elements of a window, the window decorations is either drawn by the window manager X11 or by the client Wayland. The drawing of the content is the task of the client. Under X11, when the window manager is not running, the window decorations are missing for most windows. Under Wayland, clients always draw their own window decorations. Few window managers are designed with the clear distinction between the windowing system and the window manager. Every graphical user interface based on a window metaphor has some form of window management. Next is operating modes. A GKS input device may be in any of three operating modes, which determine the nature of the interaction with the user. When a device is in request mode and the request is underway, the interaction is under the complete control of the logical input device in GKS. It is not possible for the program to intervene until the user indicates that the interaction is complete or is to be interrupted before the completion. When the device is in the sample mode, the application program can be read the current input value, which is delivered without waiting for the user to trigger the input in any way. When the device is in event mode, event reports triggered by the user are queued along with reports from any other device in event mode. The effect of having several devices in event mode is to give the user the choice of which devices to use at any time. With sample and event mode, the application program need not relinquish control. However, sample and event modes often imply several threads of control which listen to the physical device and generate the input echoes if that has to be done in software. For this reason, sample and event appear in a higher level of GKS that request. Thank you.